we're going to do another example or two of quadratic formula. So we got to be in the form ax squared plus bx plus c is equal to 0. Sometimes it's called standard form. And the quadratic formula story goes that we have a negative boy who's uncertain whether he would like to go to a radical party. Because he's a square, he misses out on 4 awesome chicks, and the party's all over at 2 a.m. We don't put the m in there because it's not part of the formula. We also say a cannot be 0. If it is 0, then it's not quadratic, so we can't have a story about it. Okay. This is one of the examples we did in class, so you can see it again. It's already good to go. It's set equal to 0. I'm going to mention what our a, b, and c's are. I'm going to do it kind of similar to what we did in classes. I'm going to find a discriminant first. You don't have to do it this way, but sometimes it makes it a little bit cleaner. So we're just substituting in for the a, b, and c. 3 squared is 9. 4 times 2 times negative 1. We have 2 negatives going on there, so it makes it a positive 8. And we get the discriminant 17, which is positive but not a perfect square, so that's going to tell us we have 2 real irrational roots. And we'll go ahead and write the formula again. Negative boy, not sure whether he wants to go to radical party. Because he's a square, he misses out on 4 awesome chicks, and the party's all over at 2 a.m. And we're going to go ahead and replace some stuff. So we're just plugging in for our A, B's, and C's. We found what the discriminant was over on the left there, so we already did that computation there. And our final answer is negative 3 plus or minus square root of 17 over 4. Maybe the My Math Lab or the textbook might want you to break it up into the 2 separate pieces, but for us, this is fine on the test. So we'll do one more. This is the last example from class. And so we got 4x squared minus 4x equals negative 7. I want it in ax squared plus bx plus c equals 0 so we can tell the quadratic formula story. So we need it set equal to 0. So we're going to add 7 to both sides. And then we will rewrite, and I will tell you what the a, b's, and c's are. Because if we don't do this, then the quadratic formula doesn't work so nicely. So again, needs to look like that, standard form. A is 4, B is negative 4, and C is positive 7 there. We'll find the discriminant again, b squared minus 4ac. That's the junk under the square root. Go ahead and plug some stuff in. For the a, b, and c, negative 4 squared 16 minus 4 times 7, which is 112. We get negative 96 as our discriminant. Because that's negative, we're going to have 2 complex conjugate roots. So we're going to have some imaginary numbers. If you're doing 1.2, they'll probably just say not a real solution. But in the sections that we do keep it real, like 1.3, or if it says to solve over the complex numbers, then you'll want to give it the 2 complex numbers. I'm going to go ahead and solve over the complex numbers just so you can get some practice with it. So, again, writing the quadratic formula, and then we'll start plugging some stuff in. So be careful with the negative b. That negative comes with the formula. B is also negative, so we have negative, negative. So be careful about that. Plus or minus, and we already figured out the discriminant was. It was negative 96. And so then we got 4 plus or minus, and I went ahead and figured out what the biggest perfect square was in the negative 96. It was negative 16. The negatives canceled on that 4 on the outside there, and then we have divided by 8. So 4 plus or minus 4i root 6 all over 8. So the square root of negative 16, the 16 part becomes the 4, the negative becomes the I, and of course 6 is not a perfect square. It doesn't have any perfect squares, so it has to stay inside. Excuse me. You can go ahead and reduce here. So what I'm going to do is I'm going to factor 4 out of the numerator. So we have 1 plus or minus I root 6 over 8. And then if you want to turn your monitors, because I'm out of room, or tilt your head, you can read what happens when I reduce. So 4 goes into 4 once, so we just have 1 plus or minus I root 6 in the numerator. 4 goes into 8 twice.